mathematicians. Today we're going to be learning about fractions, more specifically about comparing improper fractions. Before we begin, let's go over equality and inequality symbols. So here we have an equal to symbol, meaning equal to. That means that both numbers at both ends are equivalent to each other. Then we have our greater than symbol, which means that the first value we're given is greater than the second value. And then we have our less than symbol, which means that the first value we're given is less than our second value. To get us started, we have 7 over 4 and 16 over 5. And notice that both denominators are different, and in order to compare these two fractions, we have to have the same denominator. So what we're going to do is we're going to find the least common multiple between our two denominators, which is 4 and 5, so we could write equivalent fractions to then make it easier to compare. So our multiples of 4 are 4, 8, 12, 16, 20, and so forth. And our multiples of 5 are 5, 10, 15, 20, 25, and so forth. So notice that the smallest number they have in common is 20, making 20 our least common multiple. So we want to take both these fractions and write equivalent fractions with 20 as the denominator. So for 7 over 4, in order to get a denominator of 20, we have to go ahead and multiply 4 by 5. But whatever we do to the denominator, we have to do to the numerator as well. So we're also going to multiply 7 times 5. 7 times 5 is 35, and 4 times 5 is 20. So 7 over 4 is equivalent to 35 over 20. Then we're going to take 16 over 5, and in order to get a denominator of 20, we have to go ahead and multiply 5 by 4. Whatever we do to the denominator, we have to do to the numerator as well. So we also have to multiply 16 times 4. Okay? Now 16 times 4 is equivalent to 64, and 5 times 4 is equivalent to 20. So now we have two fractions with a denominator of 20 that we can easily compare now. So we have 35 over 20 and 64 over 20, and 35 over 20 is less than 64 over 20, which means that 7 over 4 is less than 16 over 5. Here we have another example where we have 14 over 3 and 28 over 6. Now, notice that the denominators are different, so we do have to find our least common multiple between our denominators. So we're going to find the multiples of 3 and 6 and find out the least common multiple. So our multiples of 3 are 3, 6, 9, 12, and 15, and so forth. And our multiples of 6 are 6, 12, 18, 24, 30, and so forth. Now, if you look at this chart, we see that they both have 6 in common, and 6 is the least common multiple that they have in common because there are other multiples that they have in common as well. So now we're going to take 14 over 3 and make it so that we have a denominator of 6. So in order to get a denominator of 6, we have to take the denominator of 3 and multiply it by 2. And whatever we do to the denominator, we have to do to the numerator as well. So we also multiply the numerator by 2. 14 times 2 is equal to 28, and 3 times 2 is equal to 6. And now we bring down 28 over 6, and now here we already have a denominator of 6, so we don't have to do anything towards it. So we end up with 28 over 6 and 28 over 6, And these two fractions are the same, making them equivalent. So that means that 14 over 3 and 28 over 6 are also equivalent. So let's do another example. Here we have 10 over 3 and 9 over 4. And notice again that our denominators are different, so we have to find the least common multiple between 3 and 4 to make it easier to compare our fractions, and then write an equivalent fraction with the same denominator. So our multiples of 3 are 3, 6, 9, 12, 15, and so forth. And our multiples of 4 are 4, 8, 12, 16, 20, and so forth. So our least common multiple in this case is 12 because that's the smallest multiple that both of these have in common. So we're going to take each of these fractions and make sure they have a denominator of 12. So we're going to take our denominator of 3 and multiply it by 4 in order to get a denominator of 12. Whatever we do to the denominator, we do to the numerator as well. 10 times 4 is 40. 3 times 4 is 12. And then we're going to take our fraction 9 over 4 and multiply our denominator 4 times 3 in order to get a denominator of 12. Whatever we do to the denominator, we do to the numerator. So 9 times 3 is equal to 27. 4 times 3 is equal to 12. And then now we have two fractions out of 12. We have 40 over 12 and 27 out of 12. And 40 out of 12 is greater than 27 over 12, meaning that 10 over 3 is greater than 9 over 4. Okay, so here we have another example. So we have 11 over 6 and 13 over 10. And again, our denominators are not the same, so we have to find the least common multiple between our denominators, which are 6 and 10, in order to find an equivalent fraction, making it easier to compare. So our multiples of 6 are 6, 12, 18, 24, and 30, and so forth. And our multiples of 10 are 10, 20, 30, 40, 50, and so forth. And notice that the least common multiple in this case is 30. So we're going to take 11 over 6 and rewrite this so that we have an equivalent fraction out of 30. In order to do that, we have to take our denominator, which is 6, and multiply it by 5. Whatever we do to the denominator, we have to do to the numerator. So 11 times 5 is equal to 55. 6 times 5 is equal to 30. So 11 over 6 is equal to 55 over 30. Now we're going to go to our second fraction, 13 over 10, and rewrite this into an equivalent fraction that has a denominator of 30 as well. So 10 times 3 is equal to 30. Whatever I do to the denominator, I have to do to the numerator as well. 13 times 3 is 39. 10 times 3 is 30. And now we have two fractions that are out of 30 that we could compare, which are 55 over 30 and 39 over 30. And we know that 55 over 30 is greater than 39 over 30, which means that 11 over 6 is greater than 13 over 10. And that's it for comparing improper fractions.